I thank you for your time, and I would now like to welcome Sean Tinsley from Flowcrete Australia.
Good morning, everyone, and thank you for attending today's webinar. I hope you'll find this of interest. My name's Sean Tinsley, and I'm the Managing Director of Flowcrete Australia, a subsidiary of Flowcrete Group, and a manufacturer of resin floor finishes. Welcome to today's Parking Australia webinar on the subject of car park decking, protection, strength, and aesthetics. The webinar will cover the following points: outlining the objectives of the webinar, specification criteria for car park decking, regulations, accreditations and testing, typical system types and build-ups, a small section about Flowcrete, followed by some actual case studies, and then to close a Q&A session. As Melissa mentioned, please feel free to ask questions during the presentation. Your input is appreciated. So the objectives of this webinar are to understand the different deck coating materials available and their applications, understanding the different factors affecting basement, intermediate and exposed decks as well as ramps, identifying the different test methods used to determine application suitability, and to identify the benefits and life cycle implications of different materials. First, let us look at multi-storey car parks. The first thing to remember about these car parks is that they are unique structures. They were first built in the mid-60s to meet the growing demand by owners and operators. There are no other buildings built like them or used like them. They have large, clear spans with minimum support to maximise the number of parking spaces. They are exposed internally as well as externally to water, chemicals and fumes. And it's estimated when a car enters the building, after it's been raining, it will bring in over 6 litres of water. The other important factor is that the building is flexing all the time due to the dynamic stress of vehicles moving up, down and along the concrete decks. They also experience cyclical stress. For example, every morning it is substantially loaded and then relieved of this load every evening. In supermarket car parks, the changeover times are even faster and more frequent than a commercial structure. As with any structure, design details that enhance durability, facilitate proper inspection and the maintenance of drainage and waterproofing will significantly extend the life and security of a car park structure. The surface of car park decks are also subject to continuous movement of vehicles braking, turning and accelerating, which can lead to a breakdown in the concrete surface, allowing water and chemicals to penetrate the concrete. This will, over time, if unchecked, lead to corrosion of the steel reinforcement in the concrete. The effects of poor maintenance or inadequate design on a car park structure can be shocking. For example, the effects of a seriously deficient waterproofing layer led to this at the Pipers Road car park in the UK. The ingress of water led to the corrosion of the steel, and the top decks collapsed onto the second and third decks. Fortunately, this happened at night and nobody was killed. The car park was, of course, immediately closed and subsequently demolished. But the incident and subsequent review highlighted that a significant improvement in performance and durability of car parks can be achieved by preventing the ingress of chlorides, having effective and easily maintained drainage, giving close attention to details during design, preventing ingress of moisture through cracks, and placing a high priority on maintenance. On this project, the lack of attention to the above factors led to the corrosion of reinforcement and wedges at the shear heads to the columns, and that significantly contributed to the collapse. Many bare concrete structures, particularly around coastal areas, have suffered from this. While coastal areas suffer from exposure to salts, inner city car parks suffer from a different phenomenon, with water penetrating through cracks in the concrete. As the water seeps through the cracks in the concrete, it collects the free lime and cement. This forms a corrosive alkaline substance which will attack and destroy car paint. This common issue can lead to significant illegal implications for the car park owners. At Flowcrete, we've experienced this on numerous projects across the world, in Australia, and in particular one that caused a local body corporate to incur several $100,000 in damages to replace a brand new car because of this effect. Clearly, this type of incident should be avoided. So what are we looking for in a suitable product to provide effective car park decking? Well, there are many factors to consider when choosing an appropriate system. It must obviously have excellent bond to the concrete. It must be resistant to cracking, particularly when exposed, as the concrete decks of car parks are always going to crack to some degree. Abrasion resistance is required to provide good wearing properties. Slip and skid resistance is needed for cars and people. Adequate fire resistance is required to allow reasonable escape time should there be a fire. And in today's climate of sustainability and care for the environment, thought should also be given to the nature of the products, the VOC content, and if, for instance, they are Green Star rated or accredited. The product should also be aesthetically attractive. The public are certainly tired of dull, dark and musty car parks of the past. Brighter car parks make parking a much more pleasurable and safer experience, and clear marking helps provide a controlled, well-managed environment for all users. The product should also dampen noise and tyre squeal, especially important if you have offices, living accommodation or retail units attached or around the car park. So we've just identified some of the critical elements of a car park product. The next thing to consider is the car park structure itself. Is it an internal or external decking? Is it a new or refurbishment project? Are there any thermal variations? What is the substrate condition? What is the level of structural movement? Where are the key locations of significant abrasion and wear resistance? Ramps and turning areas, for instance, are subject to much greater abrasion than parking bays. And what is the expected lifespan? And the product needs to be resistant to all of these contaminants, allowing these to penetrate into concrete, especially where cracking has occurred, can cause long-term degradation of the concrete slab and structure. So let's look at some typical situations with multi-storey car parks, starting with basement or lowest level decks. The basement decks can actually be quite tricky from a design perspective, as they're located below or even on the ground. Basement or low-level decks are in physical contact with the ground and require horizontal and vertical moisture proofing across the basement floors and walls in order to prevent the ingress of water or other corrosive pollutants. If the basement slab is located close to a high water table, then different moisture levels below and above the ground will result in moisture vapor transmission and inevitably put pressure on the underside of the deck coating materials, possibly leading to blistering or delamination of the surface. Below ground basement decks also tend to be very humid environments, causing substrates to exhibit higher moisture content than those located above ground. The high relative humidity can also lead to problems during the installation of resin-based coatings, resulting in blushing or discoloration of the surface if the products are not formulated to match these conditions. So what are the solutions to these issues? Well, protecting the basement decks from the effects of groundwater is clearly of the utmost importance in order to prevent any lasting or costly structural repair to the car park building. Firstly, it must be determined if a secure and intact damp-proof membrane, or DPM, has already been installed on the negative side of the concrete floor slab. If that is the case and rising moisture is no longer a concern, then DPM on the positive side of the slab is not required. However, in instances where there is no underlying DPM solution or where it has been damaged, a positive side, moisture-tolerant primer, or a breathable water-based floor finish will be required to prevent any damage to the final finish. The installation of a positive side DPM will not only allow moisture to pass through, but will also disperse any moisture vapor across a large area, and therefore prevent any point load pressure from damaging the final surface products over time. In instances where a suitable DPM has been installed and not damaged, the finished deck coating material need not be breathable, as it will already be protected from rising moisture by the DPM. It's important to determine not only if rising moisture is present, but how much is present, which can be complicated. This can change daily and seasonally. It's always best to consult a car park engineering specialist to understand this before making any final decision. If there is no threat from cyclical rising moisture, but you're working with a moist slab that has either been newly laid or is damp as a result of industrial washdown, forming part of any prep works, a moisture-tolerant primer may be used prior to installing finishing coats. There are resin coatings that offer breathable characteristics. These are generally water-based. The cross-linking density of these systems is such that a certain amount of water vapour can pass safely through the resin materials without causing it to debond from the damp substrate. However, waterborne products generally do not have the same lifespan as 100% solids products, so it's important to understand the limitations of these products before making a decision. On to intermediate decks. What are the challenges? Well, intermediate decks for multi-storey car parks are likely to be exposed to the lowest levels of thermal movement and UV radiation. They're likely to witness the most traffic abuse, as vehicles consistently use the intermediate decks to enter and exit the structure. They're likely to be subject to the most structural movement, particularly within newly constructed facilities because of these traffic. Car parks are designed, as we mentioned before, with very large spans, minimal supporting columns to accommodate the maximum number of vehicles. When subject to cyclical traffic flow, this type of construction often leaves the structure susceptible to flexing and movement. A high volume of vehicles traversing a car park structure over time can lead to dynamic loading, where vibrations impart through the decks into the structure, increasing the risk of movement across all the construction, expansion and movement joints within the frame of the structure and the decks themselves. The solution is to choose an appropriate deck coating system. In order to counteract the risk of dynamic loadings, as well as deliver a chemical, slip and wear resistant finish, a range of coating systems can be used. Crack bridging polyurethane materials have been designed to handle the unique structural movement of suspended slabs and bridge decks, and therefore offer the necessary flex to move alongside the structure, preventing cracking that may develop in the concrete substrate from reflecting through the surface of the coating, providing a long-lasting finish. Although intermediate decks are generally covered, in certain design schemes, some of the car parks may be exposed to UV light for limited periods of the day. UV-resistant polyurethane decking systems offer excellent UV resistance and will protect the finished surface from discoloration or fading. In addition, polyurethane surfaces demonstrate excellent chemical resistance and can be tailored to meet individual slip-resistant requirements to ensure safety underfoot. They're also available in a wide range of colours and offer the most durable finish for intermediate deck environments. Epoxy-free, solvent-free epoxy coating systems are more rigid than polyurethane and then will therefore not handle the structural movement as well. However, they do offer good chemical resistance and serve to protect the concrete substrate in areas where significant structural movement is not a concern. Moving on to top decks. The exposed decks of multi-storey car parks are the most vulnerable part of the building. These areas have the highest external weathering and exposure to the elements and therefore are susceptible to high levels of thermal cycling, thermal movement and UV radiation, as well as rainwater and air moisture. Thermal variations will cause the exposed deck substrate to expand and contract, imposing dynamic stresses that will inevitably lead to early cracking of the concrete substrate. The ingress of water and chlorides into the premises below could result in long-term damage to the structure and the vehicles. So what are the solutions? Roof-level parking decks are absolutely one of the most challenging waterproofing projects in the construction sector. Firstly, it's important to determine if the waterproofing requirements of the final deck coating material. If the deck coating system itself is required to waterproof the external deck slab, an elastomeric membrane will certainly be required. On the other hand, if there is a negative side waterproofing membrane already installed, in conjunction with the external slab. The top coat need not be waterproof, but it must be breathable so as not to trap moisture in the slab itself. It is critical that the waterproofing membranes are not installed both below and above the external deck slab, as it will result in moisture becoming trapped between the two membranes. When the temperature of this moisture is raised from exposure to heat from sunlight, vapor pressure will build up and risk debonding the finished system. Polyurethane coating systems are by far and away the most suitable materials for exposed or external decks, as they are flexible, elastomeric, and offer high crack bridging properties. These materials, whether applied at ground or elevated levels, will offer the most robust protection to the external stresses caused by exposure to the elements. They also exhibit a high level of UV resistance, ensuring that the colours remain vibrant and preventing any pigment shift or fading. There are also rapid curing MMA systems that equal the polyurethane. They're generally a hybrid system. They provide the performance of a polyurethane, but also are extremely rapid curing. These can be invaluable for refurbishment projects. And finally, onto ramps and turning circles. These are exposed to high levels of mechanical impact, vibration, and abrasion, and represent one of the most complex areas of the structure, as engineers and architects tend to push for shorter, narrower ramps with low floor to ceiling spaces, again in order to maximise the parking capacity and increase their revenues. In some instances, ramps are partially exposed to external weathering and rainwater, and there can be significant movement affecting the joints connecting the ramps to the multi-storey decks themselves. Application of resin materials onto steep gradients can be problematic due to the material's flowing nature. Normally an advantage on the flat areas, but can be an issue on ramps. The solutions. The selection of anti-slip profile is clearly very important to ensure the desired anti-slip properties are achieved to the right specification, depending on the ramp steepness and the location. Ramp areas demand special consideration and treatment. A higher thickness is generally required to provide the appropriate wear resistance for the ramp. Heavy-duty polyurethane or MMA coatings systems are best suited to ramps, as they offer all the materials inherent crack bridging and wear-resistant properties. The materials can also be applied at greater thicknesses and have the ability to be broadcast with stronger aggregates, including aluminium oxide, in order to ensure a strong, textured and anti-slip finish. Heavy-duty polyurethanes and MMA systems are also elastomeric and provide good crack bridging properties. So we've had a look at some of the decking requirements of the car park structure. The following section describes some of the standards and the technical approvals associated with car park decking protection systems. BSEN 1504 is the British and European standard. It details the products and systems for the protection and repair of concrete structures, its definitions, requirements, quality control, and the evaluation of conformity. Part 2 details the surface protection system for concrete. This standard is widely used across Europe and is applied both to the internal and external car park structures. To date, there is no direct equivalent in Australia. However, the following standards are relevant to the construction of a car park deck in Australia. ASNZ 2890, parking facilities and off-street parking. HB 64 2002, the Guide to Concrete Construction. And AS 3600 2009, the Concrete Structures Standards. In addition to these various standards, car park deck coating system should also meet all of the following accreditations: tensile bond strength, to ensure the coating will not delaminate or lift off the concrete; slip resistance, the coating should meet the latest requirements as per the standards below; resistant to chemicals, to ensure the products will not break down when exposed to battery acids, brake fluids and other corrosive chemicals that the cars will bring in; crack bridging, clearly important to ensure the coating is flexible and elastomeric; thermal shock. It should also be able to function during high heat and freezing temperatures. And finally, it should meet the appropriate fire ratings warranting fire research testing.
Sean, before you continue, I just have a question to present to you.
Okay.
Do you provide a two-in-one coating system for new slabs that provides both a concrete curing and surface hardener function?
Yes, we do. We have them within our range. Perhaps the person who's posted the question can email me directly, and we can certainly get back to them on that.
Definitely. Thank you, Sean.
Okay. So let's look at some typical materials often used used for the protection of car park decks. I've got 3 typical products to talk about. There are hydrophobic sealers, often referred to as a water repellent agent. Today they mainly consist of silanes and are often used on concrete to prolong the service life of the structure. This is accomplished by protecting the reinforcement bars from chlorides or by changing the moisture content inside. When the concrete is treated with a water repellent agent, the properties of the surface layer becomes hydrophobic, and therefore water droplets are stopped from entering, but they still allow water vapor to pass through the slab. This change can reduce chloride ingress and stop heavy rain from penetrating through the surface layer. There are also impregnation sealers. These are low viscosity materials which penetrate the concrete to form a film along the surface capillaries. This increases the resistance to water and other liquids without changing the appearance of the surface. Finally, there are surface coatings which form a physical barrier over the surface of the concrete itself, preventing any ingress of liquids or other contaminants reaching the concrete. From a waterproofing perspective, the key differences between the coatings and the hydrophobic and impregnating sealers is the coating's ability to bridge cracks. While the hydrophobic and impregnating sealers do provide a function, their downside is that when the concrete moves, which is generally inevitable, the seal is effectively broken, allowing water or other liquids, contaminants to penetrate through the concrete. As coating systems are often used for more critical waterproofing, there are various standards to ensure these systems are suitable. As mentioned before, the BS-EN 1504 is one of those. It details the minimum requirement for abrasion, water ingress, water vapor transmission, minimum fire ratings, as well as the flexible and crack bridging performance, and that will meet all of these requirements for at least a minimum period of 10 years. To meet these standards, the coating materials must go through a series of tests, including tensile bond, which is critical to the long-term performance of any coating system. And the bond tests are completed both in the laboratory as well as in situ site testing. The purpose of the test is to measure the materials meets the minimum bond strength of the concrete substrate. This ensures a long-term bond is achieved and the material will not lift or delaminate from the surface. The test is completed by drilling a core into the substrate to isolate the area. The steel heel is then glued onto the surface of the coating. The measuring vise is then attached to the steel heel and tightened until the heel is forcibly removed from the surface. The force taken to remove the heel is measured on the device and recorded in megapascals or newtons per millimetre squared. It then must achieve a minimum standard. Crack bridging testing is obviously fundamental for any membrane, as this determines if the material has the ability to bridge cracks in the concrete and therefore remain waterproof. The test involves inducing a crack on a concrete paver which has the coating system applied to it. The width of the crack is increased until the coating system fails or a crack is shown in the coating. A second test is a cyclic test involving repeatedly opening and closing the crack to ensure the material can accommodate dynamic cracking. This is critical as cracks in concrete will continue to move when the structure is loaded and unloaded, and when the concrete heats and cools through the thermal variations through the day or the seasons. Abrasion testing is also completed to ensure coatings are able to accommodate the wear from car traffic. In this test, the coatings are subjected to abrasive aggregates being moved repeatedly over the surface. The product is weighed before and after the test, and the loss of weight is recorded and measured against the standard. Fire-resistant testing is also completed by exposing the product to a naked flame. The test is to determine the time it takes for the product to start to burn, and again must meet a minimum test standard. Finally, the coatings are wet slip tested to ensure they meet the minimum requirement. The test involves swinging a pendulum arm over the surface of the coating. The pendulum has a rubber shoe on the end of it to replicate the heel of a shoe. As the shoe passes over the surface, the amount of friction or coefficient of friction is measured by the machine. Slip-resistant testing has recently changed with the implementation of AS 4586 2013. In general, the level of slip resistance required in car parts has actually increased from the previous standards.
Sean, I've got a question for you. Sorry to interrupt. What slip resistance is required throughout the car park?
This depends on the area itself, but generally, internal areas require a P3, as per the slide there, 35 to 44. The two slides indicate different types of rubber, but a P3 for internal, the external decks are P4, and ramps generally a P5.
Thank you.
A car park deck must also provide clear line marking. There are local regulations which dictate the size of the arrows and how disabled bays must be marked out. It also provides the opportunity to further enhance the environment by providing specific areas for female and parent parking, as well as parking for electric charging, amongst others.
Sean, I've got another question on this slide before you continue, if you don't mind. What are the best line marking materials to use, because some seem to wear out quickly?
Chlorinated rubber is often used for line marking within the car parks. It's very quick, it's cost effective to install. So for the parking bays, generally this is a very good option. They don't have the same amount of traffic, so they'll last a long time. However, the directional arrows, particularly on the turning areas, can tend to wear quite quickly. They can maybe last a year or two at most in some car parks. So polyurethane products will last much longer. So really a combination of chlorinated rubber and polyurethane is a good option, both for longevity and financially.
Thank you.
The final requirement for coatings is that they should provide a service life between 10 and 20 years, with a surface that can be regularly and easily cleaned with a rotary scrubber with neutral detergents. Okay, so the following slide shows images of the processes involved in applying a waterproofing top deck system. So this starts with surface preparation, arguably the most important process to ensure the coating materials remain firmly bonded to the concrete substrate throughout its lifespan. Surface preparation is completed mechanically using vacuum-controlled shot blasters or diamond grinding. This process is completed on new and old concrete with the objective of removing any surface contaminants and providing an open textured surface for the materials to adhere to.
Sean, sorry, before you move on, I have another question for the maintenance side. Is it important to clean a car park, and what is the best method? Sorry.
Oh, for cleaning? Okay, I'll just go back to that slide. Well, the best method is certainly with rotary scrubbers or mechanical equipment. Ideally, these units should be enclosed so they can pick up any waste. However, the coatings are obviously very, very tough, and they can be easily cleaned with power washing. But you need to consider how you deal with the wastewater if you're going to use a gurney, for instance. Is it actually required? What you need to consider, it's a bit like with your car. If you don't clean your car, the car isn't going to break down. However, if you keep it maintained, the car park is always going to look at its best. The other advantage is that it will extend the life of the coating. The coatings are always warranted for at least 10 years. The life expectancies are at least 15 years. But if you regularly clean them, the contaminants can be removed. If you imagine you've got fine particles, they will actually act as an abrasive layer when the cars run over them. So if you remove those through the cleaning process, you're clearly going to extend the life of the coating. This is most important on the intermediate decks. The external decks, because they get rain, they're not entirely self-cleaning, but they certainly don't require the same level. So like anything, the good maintenance just extends life and makes the aesthetics much better. But it, is not 100% required.
Thanks, Sean.
Okay. So yeah, back to the preparation methods. Existing line marking is generally removed by scarifiers and/or diamond grinders on an existing car park refurbishment.
Sean, with completing this, is it essential to do it on new concrete as well?
All preparation is required whether the concrete is brand new or 20 years old. When a brand new piece of concrete is laid, it has a certain level of surface latenance, which is neat cement on the surface. So even if it's a brand new piece of concrete, it still requires surface preparation to remove that weak layer on the surface to provide an open texture for the resin materials to bind onto. So yes, it is required on all concrete.
Thank you.
Okay. So after the surface preparation is completed, and we're talking here about a top deck waterproofing system, one of the first things that's completed is that all the existing cracks, generally over 1 millimetre wide, any daywork joints in the concrete, are reinforced with a flexible membrane layer. The image here is showing that obviously it's liquid material. It's poured over the cracks, and that provides additional crack bridging performance in these locations. The good thing about old projects is that you see very clearly where the concrete has actually moved, and so you can clearly identify where you need these additional layers of reinforcement. On new projects, it really comes down to the type of structure it is. Suppliers like ourselves obviously have lots of experience and can predict to a certain degree where the layers are going to be needed, which require extra reinforcement. So after that is completed, the next stage is priming. Now this is actually done over the entire area, including over or next to where the banding was first installed.
Sean, I have a question on the priming, if you don't mind.
Yeah.
Is the material always applied with a roller, or can you spray it?
The materials, there are various materials in the market. The ones we're showing here are designed to be applied with rollers. So there's no expensive spray equipment required. The process is very quick. I mean, they're using large industrial sized rollers here. They are 430 millimetres wide. So a 4-man team will easily install 1,000 metres a day or around 100 parking bays.
Excellent, thank you.
Okay. So once the primer is installed, any major defects in the concrete, particularly on older slabs, are repaired using flexible repair mortars, particularly where there may be low spots in the concrete. The membrane layer is then applied over the dried primer. This is applied with a notch squeegee and a large industrial roller. The applicator wears spiked shoes, which allows them to walk over the wet material to complete the installation. A second coat, or what we call a body coat, is then applied over the cured membrane. And whilst this is wet, the slip-resistant aggregate is scattered into that wet surface. As soon as that is dried, any excess aggregate is removed, and then the coloured top coat or coats are then applied over the entire area. Again, this is installed with a squeegee and roller. And any of the upstands, drainage, all the details work are completed simply with a paintbrush. So for a top deck, the typical build-up of the system involves 4 or 5 layers. It starts with a penetrating sealer or a leveling primer, followed by an elastomeric crack bridging membrane, then a body coat layer which incorporates the slip resistant aggregate, and then finally a coloured UV resistant wear coat. For intermediate decks, there are typically 2 specifications. Internal ramps and all turning areas require a 3-coat system, including a combined primer and body coat, which incorporates the slip-resistant aggregate. That's then followed by a coloured lock coat, and then a third high abrasion-resistant coat is then installed over the top of that. All parking bays and straight driveways require a 2-coat system only, which uses a combined primer and body coat incorporating the slip-resistant aggregate, and then followed by a lock coat. For areas which have limited access, there are also very rapid cure materials available. As mentioned earlier, these are based on a hybrid which combine polyurethane technology and MMA, which is methyl methacrylate, which provide very quick curing. So these coatings cure within 15 to 30 minutes between the coats, and they're ready to receive full traffic in less than 90 minutes after the final coats are applied. So this can be particularly beneficial when completing external waterproofing, as the surface is required to be dry prior to the application. Inclement weather is always a potential problem, so rapid curing MMA systems can easily overcome this. They're also used frequently for entry and exit ramps where the absolute minimum downtime is required. The build-up is very similar to polyurethane systems and includes an MMA primer, flexible membrane, a wear coat incorporating the slip-resistant aggregate, and then a final UV-resistant coloured finish coat. So to summarise, multi-storey car parks are unique structures requiring unique waterproofing and decking solutions. The decking systems offer excellent performance characteristics with proven track records and installed by an approved applicator network. The specifiers have many options available to them for both new and refurbishment projects to meet these requirements of their design criteria, providing functionality with high aesthetics. Okay, I would now like to just give you a brief overview of Flowcrete and its history and demonstrate where car park decking fits into our project range, and then followed by some actual case studies which will give you, hopefully, pull together everything we've talked about on this webinar. So Flowcrete was founded in 1982 in the UK, and over the past 32 years expanded into a global enterprise with 8 strategically located manufacturing facilities and 30 sales offices serving around 85 countries on an annual basis. Our global material turnover is over 150 million, or approximately 400 million in contract terms. Car park decking is a major product line for us within the business, and successful projects can be seen throughout, locally here in Australia and New Zealand, Europe, the Middle East, Asia, and the Americas. So beyond car parks, here you see the diversity of our range. Flowcrete supplies resins for various industrial, engineering, manufacturing facilities. We have special antimicrobial resins for use in high hygiene sensitive environments. We have a range of fast-curing methyl methacrylates, or MMAs, which cure within an hour or two. And we have a range of seamless terrazos and decorative but functional resins, typically located in or used in schools, shops and offices. And of course, we have our car park deck system. So to finish, the following slide shows some case studies of car park decks treated with a flexible deck coating product. So this is the Star Casino in Sydney. This project used a polyurethane coating to great effect by really just a simple use of colours and some excellent detailing. Phase 2 of this project was recently started, only last month, and it will be our largest project in Australia to date. The installation will be over 70,000 square metres, or approximately 3,000 parking bays. This is a 50,000 square metre car park, or 2,500 car spaces, which utilise an MMA and polyurethane deck coat system. The coating system was used to provide a trafficable waterproofing system to the top decks and a trafficable system to all of the intermediate decks. The simple use of colours on this polyurethane system was used to great effect on this project in the UAE, providing a very modern and attractive environment. This project in Thailand used fine details around the car park bays and walls to create quite a sophisticated look on this commercial car park in the city centre. This retail mall utilised different colours on each floor to provide easy identification on all the levels. This simple design on this car park in China really highlighted the light reflectivity on what was a super-sized project in Shanghai. This was a unique structure or project in Dubai. It was completed with our polyurethane system. All the work had to be done at night only, as the temperatures in the day were over 50 degrees. And this project here used a rapid curing MMA system to provide the trafficable waterproofing system for the helipad on a upmarket hotel in Shanghai. So if you want to find out more, obviously you can visit our website, www.flowcreteaustralia.com.au, or you can, of course, contact me directly. Thank you for your attention, and please feel free to ask any questions.
Excellent. Thanks so much for your time, Sean. I'll just give people a few seconds just to see if we have any final questions. But I would like to say thank you for your time today and your presentation and the information that you presented us. It was fantastic. I'd also like to thank the attendees for attending today. And if you do have any further questions before you leave the webinar, please feel free to put them in the chat box, or you can email them direct to Sean or myself. I will be emailing all participants a feedback form after the event today. If you could please fill this in, it would be a great help as we want to perfect our webinars and obviously improve your experience with us. Members, don't forget as well to visit the Outlook pages of the Parking Australia website for all recent updates regarding our upcoming conference and Parking Industry Awards for 2015. So if I have no further questions, I would like to say thank you again, Sean, and thank you everybody for attending, and we do hope to see you at future Parking Australia events. Thanks everybody.
Thank you.
Thanks, Sean. Thank you.